As we have already seen how to implement a filter for the distorted signal using MATLAB, now we will see the same thing using DSP TMS320F28335. As to implement this filter, we want 5 coefficients, namely the distorted input signal, the desired filter coefficients, and the Hamming window coefficients, and the final filter window coefficients, and the output signal. We have taken X as the input signal, HD as the desired frequency, desired filter coefficients, W as the Hamming coefficients, and Hn as the final coefficients of the filter, and Y as the output. As since CCS cannot display or plot the 16-bit decimal values, we have to multiply with 10 power x values for this input signal, as we have taken the 5 variables for each of the input signals. And n is equal to 11 denotes the length of the filter coefficients, and n, I, j we are using in the program as the index variables. Now here x is the input distorted signal, which contains fundamental frequency of 50 Hz, third harmonic, fifth harmonic, and seventh harmonic. We are multiplying these values with 1000 as CCS cannot display the decimal points. Again, in this input signal we are taking from 0 to 100, so this will contain 101 values, and the length of the filter coefficient is 11. So the total number of the output signal will output samples will be 101 plus 11 minus 1, that is 111. So we have to pad the zeros to the input signal for the remaining samples. So that is done in this for loop. From 101 to 111 we are padding the zeros to the input signal. Again, in this loop we are finding the coefficients of the desired filter using this formula, as we have already seen in the MATLAB example. And this is to find the coefficients of the Hamming window, as we have already seen. Again, we have to pad the remaining samples of both the Hamming window and the desired filter coefficients to zeros, which is done in this loop. And to get the final desired frequency filter, we are multiplying with desired frequency filter with the Hamming window, and we are multiplying each of these filter coefficients with 1000, as CCS cannot display the 16-bit decimal points. And this for loop gives the convolution of the input distorted signal with the final filter coefficients, and the output is the 1000 multiplication of the output signal to display it in the CCS window.